So you've tried learning React, right? And you've probably figured out pretty quickly it's not just about memorizing some syntax. It's a totally different way of thinking about how to build things for the web. Well, today, we're going to unlock that mindset together. You ever use a modern app and it just feels alive? You click a button and the page changes instantly right in front of you. There's no waiting, no clunky full-page reload. How do they do that? That's the magic we're going to pull apart today. And let me tell you, a huge part of the answer is this way of thinking that React really perfected. Okay, so where do we even begin? It all boils down to one simple but seriously powerful idea. We're going to build our user interfaces out of reusable, independent blocks. Think of them like Legos for your website. At its heart, React is really all about one thing: building the stuff the user actually sees and interacts with. It lets us create these custom building blocks, which we call components. And here is the real magic trick. It's designed to automatically update what's on the screen whenever our data changes. That is the core promise of React. Now, to describe what these components should look like, we use this thing called JSX. And yeah, I know, it looks exactly like HTML, but don't let that fool you. It's 100% JavaScript under the hood. The secret decoder ring is right there, the curly braces. Think of them as a switch. The moment React sees them, it stops thinking in HTML and starts executing JavaScript. That's the bridge between your layout and your logic. So what even is a component when you get right down to it? Honestly, it's just a JavaScript function, but it has one very special job. See, a normal function might return some data, like a number or a string. A React component, on the other hand, returns UI. It returns that JSX we just talked about. That's it. That's the fundamental difference, but it changes everything. Okay, let me give you a quick pro tip that will instantly make your code so much cleaner. It's called destructuring. Instead of pulling things out of an object one by one, which gets really repetitive, you can just grab exactly what you need in one single clean line. This is not just about typing less. It's about writing code that's readable and easy to maintain, especially when you're dealing with a huge response from an API. All right, building with static blocks is cool and all, but how do we make them interactive? How do we give them a memory so they can remember things? Well, that brings us to the absolute heart and soul of React, the power of state. You hear this word state thrown around all the time, but what does it actually mean inside of a component? This is probably the best analogy you'll ever hear for it. Just imagine every single component has its own tiny whiteboard. This whiteboard holds any piece of information that can change over time. What a user is typing in a search bar, how many times a button has been clicked, you name it. And whenever you update that whiteboard, React sees the change and automatically redraws that part of the screen. And this right here, this is the whole game. If you try to use a regular JavaScript variable, it's like writing on a piece of scratch paper that React isn't even looking at. You can change it 1,000 times, but the user will see nothing. State is the special kind of variable that React is obsessively watching. The moment it changes, alarms go off inside React, and it triggers a re-render. So, how do we get one of these magical whiteboards? We use a tool from React called the useState hook. It's a really simple three-step dance. First, you declare your state and give it a starting value. Second, useState hands you back two things: the current value itself and a special function to update that value. Third, whenever you want to make a change, you call that special function. That's your signal to React that it's time to update the UI. This whole idea of state becomes an absolute superpower when you start working with forms. A controlled component is basically just an input field where we've told React, you're in charge now. The value of that input isn't stored in the HTML anymore, it's stored directly in our React state. This gives us one single reliable source of truth for all our form data, and that makes everything so much more predictable. So our components can remember things now, which is great, but they're still kind of living in their own little bubble. To make our apps actually useful, we need to connect them to the outside world. Fetch data from a server, talk to an API, and that's where side effects come in. For any of these interactions with the outside world, we use another hook called useEffect. Now, side effect sounds like a complicated, scary term. It's not. It's just a fancy name for any work that isn't directly part of rendering the UI. And what's the number one most common use case? Fetching data from a server the moment your component first appears on the screen. Now pay attention here because this is one of the most critical patterns in all of React. When you pass useEffect to this empty array at the end,
You are telling it, hey, run this code one time and one time only, right after the component shows up for the first time. This is the perfect go-to recipe for fetching your initial data without accidentally creating an infinite loop of requests.
We've built these awesome dynamic components, but real apps have more than one page, right? They have different views. So how do we handle navigating between them without those awful old-school page reloads? This is where the whole idea of a single-page application, or SPA, comes into play. The entire app lives on one single HTML page that loads just once. Instead of fetching a new page from the server every time you click a link, we use a tool like React Router to just swap out components right there on the client side. It creates this perfect illusion of navigating between different pages. And to make this work, there is one golden rule you absolutely cannot break. You have to replace all of your normal HTML A tags with the special link component from React Router. They might look the same to the user, but their behavior is completely critically different. So what happens if you use the wrong one? Well, the first consequence is immediate and obvious. You use a regular anchor tag, and it triggers a full page reload, which completely destroys the whole point of having a single page app in the first place. But this is the real killer. When that page reloads, your application's entire whiteboard, all of that state you've been carefully managing, everything the user has typed, every selection they've made, it all just gets wiped out. Instantly. It's a catastrophic reset. This is why using LINQ is absolutely non-negotiable. All right, one last core task. Almost every single application you build is going to need to display a list of data, a list of products, a list of users, a list of posts. Let's make sure we're doing this the right way. When you render a list in React, you have to give each item a special prop called a key. It's like a unique name tag for each element, so React can keep track of it if the list changes. Now, you might be tempted to just use the item's index in the array as the key, but that is a risky move. If the list gets resorted, the indexes all change, which can totally confuse React and lead to some really weird bugs. The best practice, always, is to use a stable, unique ID that comes with your data. So let's just do a quick recap of our toolkit. We have components and JSX. Those are our blueprints. We use state to give those blueprints memory and make them dynamic. We use effects to connect them to the outside world, and finally, we use routing as the map that lets us combine all of our components into a full multi-page application. These are the fundamental building blocks. You now have the mental model to really understand how modern, responsive user interfaces are built from the ground up. So the only question left is, what are you going to build with it?